To determine the cause of the massive power failure that occurred in the Tokyo metropolitan area last night, the government has established a special crisis task team under the direct control of the Prime Minister's office. While some have mentioned the possibility of cyber attack, the cause of the power failure remains unknown.
You have just witnessed an example of a cyber attack that could happen in the near future. In this hypothetical case, the result of a cyber attack was the temporary shutdown of the city's entire power network. Although such a large-scale cyber attack has never happened within Japan, other incidents overseas have been reported over the last several years. Japan will not be able to remain immune to the threat of cyber attacks. In response, the country and private sector working together to improve the security of control systems founded the CSSC in Tagajo City, Miyagi Prefecture, in order to protect Japanese industry from this kind of cyber attack, as well as to increase competitiveness in exports through a high level of security.
Let me introduce the testbed for the CSSC. The most notable feature of this testbed is its plant simulations, which extend across 7 industrial sectors and are equipped with a total of 9 systems. To say a little more about plant simulations, their control mechanisms and concepts vary greatly by industrial sector. From here, let's take a closer look at the various simulated systems. This is a drainage and sewage treatment plant. This models a part of the settling tank that performs the separation of a great deal of used sludge and water in wastewater treatment, where a controller must maintain a constant volume of water flowing to the settling tank. Moving on, we have a building control system. Looking at a system for controlling the lighting and air conditioning of office buildings. Actual lighting control can be carried out in this simulated plant room, so as to more directly experience the impact of cyber incidents. This is an assembly plant. The robot control system used in automotive assembly has been reproduced here. During the assembly process, since a small control deviation can greatly reduce the quality of the product, precise control increments of 0.01 seconds of 0.01 millimeter units is required. This is a training simulator equipment installed at a coal-fired power plant. Power plant operations staff use the simulator in practical training so as to experience the behavior of a cyber incident occurrence. Next to it is a process control system that mimics a part of the city's gas supply system. It controls the constant pressure of the gas tank. This plant copies a part of the automotive assembly plant's robots. The robot arm sorts through parts and then transfers them onto the base where they are marked by a laser. This control center and substation of the simulation system are very important facilities that make up the smart city. In the exercise, one can experience what events might transpire in the smart city during a cyber attack from outside. Even in rooms other than the plant simulation room, 2 plant simulations have been installed. One is a chemical plant installed in the system assessment room. This is also a process control plant and is set to maintain a constant level in the water tank. Last is a building automation system installed in the exercise room. This is modeled after a system for controlling the lighting and air conditioning of office buildings. Although it has the same functionality as the prior office building automation system, Elements such as the system's OS and communication method are different. Exercises performed in these 7 sectors and using these 9 systems of simulated plants are newly developed each year through programs that correspond to the perspectives provided by active staff working with the controls in each field, system administrators, and even other managerial staff.
Now, let me introduce the major activities in which CSSC is engaged. The activities of the CSSC consist of 4 main pillars. They are the development of highly secure technology for control systems, the development of evaluation and authentication techniques, the development of incident analysis technology, and the conducting of public awareness activities related to cybersecurity as described earlier. In the development of highly secure technology, research of terminal servers, firewalls, switches, and other elements involved in whitelist implementation and so on are ongoing. In developing evaluation and authentication techniques, we are the first institution to receive EDSA certification in Japan. This certifies that devices such as controllers of the entire control system meet international security standards for devices. With CSSC performing this authentication, we will be able to enhance the international competitiveness of Japanese control device vendors. Lastly, in the development of incident analysis technology, research is being conducted of analytical techniques using a crosslog throughout the entire system, including communication devices, security devices, terminal servers, control devices secure logs of accumulated technology, and so on. This, and early detection of incidents even more so, is central in the development of technology aimed at maximizing deterrence of cyber attacks. The CSSC, through these activities involving the security of control systems, will also continue to contribute to post-earthquake reconstruction in the Tohoku region where it is based, and contribute to disaster mitigation.